Okay, so this is problem 1.4.75, and they ask us to use the quadratic formula to solve the equation, and you probably can't read that. It's 5x squared minus 7x equal to 3. So let me write it bigger. 5x squared minus 7x equal to 3. Okay, and we are trying to solve this using the quadratic formula. So the first thing is, when you're going to use the quadratic formula, you have to have your equation set to 0. So the very first thing I need to do is subtract 3 from both sides, so that I have 5x squared minus 7x minus 3 equal to 0. Okay, and now I'm going to use this formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, the a, b, and the c in this formula refer to the coefficients of our terms here. So if we look at a basic quadratic, ax squared plus bx plus c equal to 0, that's where the a, b, and c are. Okay, so for our particular quadratic, the a is 5, the b is negative 7, and the c is negative 3. Okay, so if we stick those into our formula, we have x is equal to negative b, and b is negative, so we need to keep track of that. B is negative 7, so plug that in, opposite of negative 7, plus or minus the square root of b squared, so that's negative 7 squared, minus 4 times a is 5, and c is negative 3. Okay, and that's all over 2 times a, and a is 5. Alright, so we just need to simplify this now. So this is x is equal to 7 plus or minus the square root of 49. Negative 7 squared is 49. We have two minus signs here, negative 4, negative 3, so this is going to become plus, and we have 4 times 5 is 20, times 3 is 60, and this is all over 10. Okay, so let's simplify here under the radical. So we have this right here. It's going to be 7 plus or minus the square root of 49 plus 60 there. You're going to have 109. And then all over 10. Now, we need to think about whether 109 will actually simplify or not, and whether it's got any perfect squares in it. So, looking at it, I don't believe it's divisible by any perfect squares. So we would leave our answer here. This is actually two different solutions. 7 plus the square root of 109 all over 10, and 7 minus the square root of 109 all over 10. Okay, and when you go to input this into the computer, it may not allow you to do this in the numerator. It might. The other way that you can input this is you can say it's 7/10 plus the square root of 109 over 10. The 10 is dividing both of these, and then 7 over 10 minus the square root of 109 over 10. Either of those will be acceptable answers. You might need to play with how you plug it into the computer. Okay. All right, so that's 1.4.75, and then this question was also asked in section 1.4. It's problem 1.4.109, and I'll read this to you. Let's see if we can. Nope, not going to be able to read it. Okay, so what this says is we have an open box, and it's to be constructed from a square piece of sheet metal by removing a square of sides 6 feet from each corner and turning up the edges. And they're giving you a picture. I'll draw this out bigger. And then they say if the box is to hold 864 cubic feet, what should be the dimensions of the sheet metal? And then we want to know what is the length of a side of the square. So actually they're asking two questions there. That's a little bit confusing, but the one that they want you to input the question for is, what is the length of a side of a square of sheet metal? Okay. All right, so let me paraphrase this problem. They're saying that we have an open box and it's being constructed by removing a square of 6 feet in the corners, essentially. And then the box holds 864 cubic feet. That's a volume. And then we want to know essentially what is the length of a side of this. Okay. So first of all, if we just draw ourselves a picture here, I'll make it rather big. Okay. What's happening is you're starting with a square, essentially, and you're cutting out corners that are 6 feet by 6 feet. Okay, so this distance right here, that is 6 feet. And this right here is also 6 feet, and that's happening for each of these corners. Okay. And then they're also saying on the diagram that this whole side right here is x, and that's actually what should be the dimensions of the sheet metal. Length of a side of the square. Okay, well, anyways. And so if this is x and we're talking about a square, then this is also x. Okay? And if we take a look at this, if this is 6 feet right here, and this is 6 feet right here, then this distance right here is actually going to be x minus 12. Okay, and that's the reason is if this whole thing is x, then you know, this, if I subtract 6 here and subtract 6 here, then I'm actually subtracting 12. That would leave me this distance right here. Okay, now the reason that I'm interested in that is because they're giving us a volume here, and volume is defined as length times width times height. So I need to know what the length is, I need to know what the width is, and I need to know the height of this box in order to be able to use that value. So x minus 12 here, I can think of this as a width. And you know, the length, we're talking about a square here, is going to be the same thing, so it's x minus 12. The height, if you can imagine this, if you've cut out 6 feet right here, if you fold this up, it's actually going to have a height of 6 feet. So if I plug this into my formula, I actually have x minus 12, that's the length, times the width, which is x minus 12, times 6, which is the height. And I want to solve this, so I can actually, I want to plug in 864 for the volume. So 864, I'm going to bring the 6 out front here, is x minus 12 times x minus 12. And we just now want to solve this quadratic, essentially. Okay. So if we go ahead and FOIL, then we're going to have 6 times, first here is x squared, outside's negative 12 and inside's negative 12, so that gives me a negative 24x, and the last is a positive 144. Now, I could go ahead and just take this 6 and distribute it through, but since I'm trying to eventually get this 864 over here anyways, I'm going to go ahead and just divide both sides by 6. That allows me to get rid of that coefficient. Okay, so what we're looking at then, if you take the 864 and divide by 6, you have 144. So we have 144 equals x squared minus, minus 24x, and then plus 144. If I want to solve this, let's set to 0, so subtract the 144 from both sides. And you can use the quadratic formula on this if you want, but this is factorable, so factoring is a lot easier. I'm just going to do that. So if I factor out an x here, then I'm left with x minus 24. And I can set both of these pieces to 0 using the zero product rule. Add 24 here, x is 24, and x is 0. Now, x equals 0 makes no sense in the context of this problem. That would be a sheet metal that has 0 feet for length, and then you don't have any sheet metal, right? So that doesn't make any sense. Let's cross that off. But this one does make sense. And if we go back to our diagram here, x is this whole length right here. And that actually is what they were asking for. They wanted to know the length of a side, and I didn't write it out properly, but it's the side of the square piece that you start with before you cut things out. So, square piece of sheet metal. So the x is actually what they're looking for, not the x minus 12 portion. So 24 feet would be the answer on that problem. And that's it.